Welcome to our presentation of our biopsych project, the Roundabout Effect. We are going to start with history and transition into our experiment. Enjoy the experience.
Starting in ancient times, Rome was the foundation of modern transportation. They created the first system of roads and city blocks for easy travel and direction. After Rome perfected this idea, many other nations began to adopt this idea. Before the era of motorized vehicles, accidents weren't much of a common occurrence. However, after Henry Ford provided the common man's car, traffic as well as accidents increased exponentially. As a result, engineers began to search for a safer intersection.
Even though Rome perfected the straight road systems, they incorporated another style of roads called circular junctions around important buildings. These were the first attempt at a roundabout idea. Even though it was an archaic concept, European engineers adjusted this plan to reduce the severity and number of accidents at busy intersections. Prior to the 1990s, Europe was the exclusive user of roundabouts until the United States began to adopt the concept after seeing success in Europe. As well as utilizing the idea, engineers here noticed the left-hand turns caused the majority of accidents, so they made the roundabouts free of left-hand turns.
Between the traditional intersection and the roundabout intersection, both have their pros and cons. For a traditional intersection, the greatest pro is that everyone is familiar with them. As well as familiarity, they cost less to make and maintain as well. Besides this, there are a couple of cons that go along with them also. The first is normally these intersections have high speeds leading to a stop sign or stoplight, also causing the temptation to go right through the stop. No cop, no stop effect. Another major concern is that the flow is across oncoming traffic, which causes congestion and accidents.
As we start to see the shift from intersections to roundabouts, there are many pros as well as cons. The major pro with roundabouts is that they keep traffic moving at all times. The speed of entry is also much slower, reducing severity of any accidents that do occur. When traffic is low to moderate, no intersection can compete with the efficiency and safety of a roundabout. However, as traffic moves beyond moderate, we start to see more congestion and more frustration. This stems from people still learning to successfully navigate through a roundabout because of how new they still are.
Because of the pros and cons of both intersections, we decided to test the roundabout idea in a school environment. Some of the motivating factors behind this are observations our group has made through our 4 years at the high school. These include groups of friends gossiping in the middle of the hallway, bumping, shoving, and confusion at all major intersections, and many awkward situations. All of these led to our roundabout idea, which also happened to incorporate biological and psychological aspects. Starting with biology, we notice a lot of neural activity was used in navigating a roundabout. For example, our mirror neurons fire when we see the first person go around the circle, and as a result of this firing, we naturally want to follow the same pattern we observed. Another thing to consider is how quickly these actions happen. This is due to our billions of neural connections in our brain firing instantaneously. The yield sign at the entrance of the roundabouts is very similar to the action potential of neurons. Basically, the neurons reach threshold and the signal sends, or the neurons don't reach threshold and the signal doesn't go at all. This is similar to the yield because either you stay or you go based on the signal you get from drivers already in the roundabout. Finally, roundabouts are entering society based on a concept like natural selection because they are a mutation to our transportation system that, if successful, will continue to develop in our society.
The overlap between biology and psychology is significant. However, there are a few specific things related directly to psychology. For example, the main idea behind the roundabout is observational behavior. We watch the students explore the roundabout and maneuver the new intersection. Through our experiment, we shaped the students to get the results we wanted using our experimental stages. Another concept is latent learning. Many of the students already know how to use roundabouts from driving class or observing their parents use them. The latent learning took place when they were put in a situation involving moving around the roundabout.
Our procedure took place in 4 steps. The first step was simply observation, watching how the students went through a traditional intersection. The video shows here that the flow is decent, however there are still times when the situation would become awkward and congested, as shown in the next 3 videos. In the first video, notice how some people get cut off and the insanity of crossing traffic. In the next video, we can see the issue with people blocking the middle of the hallway. Finally, in the third video, we can see more confusion coming from the cutting of people across the traffic.
Our second stage consists of a common occurrence seen in the high school: people standing in the middle of the hallway. The video shows some of the problems created by groups clustered in the halls. As seen in the first clip, almost immediately there is a collision created by the group. People who form the groups don't consider others that need to get through the halls. Because of these groups in the middle, people begin to take the shortest path, which often results in collisions.
Our third stage was placing our makeshift roundabout into the hall without any instruction. The purpose of this was to observe traffic flow as well as how people reacted to an object in the hallway instead of a group of people. Here we can see a lot of the people are following the flow, and then there's some cutters here and there. This first clip shows many people firing their mirror neurons and successfully following the flow of traffic. This is how the roundabout's supposed to work. As seen in the second clip, those who travel the wrong way along the shortest path cause problems for those trying to follow the flow. Again in the third clip, it's apparent the effects of misuse during the flow on the traffic.
Our final stage was to place directions along with the makeshift roundabout for the students to follow. The purpose of this was to demonstrate the effect of a fully functioning roundabout. As seen in the first two clips, the students demonstrate recognition in that they navigate the roundabout successfully. This clip demonstrates the mass confusion created when someone goes the wrong way, even though the rules are clearly labeled. This final clip shows that even though the rules are posted, but because there is no authority or traffic, people feel entitled to go whichever way they want. Essentially, a no cop, no stop effect.
In conclusion, we found that the concept can work if the students obey the given rules. However, there are always people who don't follow the rules and mess up the entire system for everyone else. Clearly, based on the amount of confusion and collision observed in stages 1 and 2, something needs to be done about traffic in the hallways. Whether roundabouts are the right idea, further testing would need to be done. Through our observations, it has potential to succeed. Some things we would change to make the experiment more successful are a more professional roundabout, using the roundabout during more hours of the day and over a longer period of time for testing, and finally installing a real roundabout in a new building to see its effectiveness.
On a final note, we just have some ideas on future applications regarding roundabouts in pedestrian environments. Some high traffic areas such as college campuses, malls, and airports seem like viable areas to use these newer intersections.
Here's a special thanks to all the people that helped us accomplish this experiment and with all the setup and takedown of everything that we did. Thanks for watching our presentation. We hope you enjoyed it, and if you have any questions, feel free to ask.